Okay, let's start. Let's start. Write down topic trigonometry. Trigonometry. Write down topic trigonometry. Okay, now say this on all. Trigonometry, very important lesson. Trigonometry, very important lesson. So for your A-level examination, pure mathematics, there will be part B question number 17, full question. Part B question, then 15 marks for that. And again we have part A, question number 10 will be again trigonometry. It has 2.5 marks, then altogether 17.5 marks for direct trigonometry question. Okay, direct trigonometry. Then this is very important lesson for your A-level examination. And other than that, so for dynamics part and statics part in applied mathematics, we have to do some trigonometric simplifications. And also for differentiation, for integration, we have to do trigonometric simplification. Then trigonometric, very important lesson because of that. Okay, and this is very simple lesson, but we have to practice that real well. Okay, we have to practice A to Z. We have to practice it well. Okay, now you just identify. So in pure mathematics, we have four special sections. So one is algebra, the other one is calculus, the other one is coordinate geometry, the other one is trigonometry. Four special sections. Then trigonometry, one of that. Okay. So under algebra, we have different sections: quadratic, then polynomials, inequalities, logarithms, matrices, complex numbers, and so on. We have different subtopics. But under trigonometry, it is one unit. Trigonometry, one unit. Okay, this is very important part. So you have done under O levels small things about trigonometry. You know about trigonometric ratios. Okay, you know things about trigonometric ratios. That means you know sine, you know cos, you know tan. So other than that, you don't know anything. But we have to analyze many things about trigonometry. That is the specialty of this one. Okay, the basic concept of trigonometry is about an angle. So we have to deal with angle first. Okay, then we have to discuss angle first. So you consider a line segment like this. Say OA. So about this O, this line segment, you say it is rotated. Let's say second position A dash. A and A dash. Okay, that is rotating. Therefore, this initial and end position we can measure the portion of rotation we measure by angle. That is our definition of an angle. And here we have different types of angles. You know the things about angle, no? You know how to measure angles. Then 30 degree, 60 degree, likewise you can measure angles. Then here an angle, then initial position, end position, difference we can measure by the angle. So here it is the things about rotation. So that is the basic concept of trigonometry. And further, so when you consider a line segment like this, if it rotates anti-clockwise sense, we say that is positive angle. And if that rotates clockwise sense, we say that is negative angle. Then for angle also we have angle signs, positive angles and negative angles. So you consider here positive angle, then negative angle. Okay, then positive angle, negative angle. So further you consider eye level and angle of elevation and angle of dispersion. Likewise, further we have angles. Then here we consider trigonometry to analyze three-dimensional thing. Then here two-dimensional angle. But further we have three-dimensional angle. You consider line segment. I'm going to rotate that one like this. then here this vertex, there will be angle called three-dimensional angle. Then but we consider only about two-dimensional angle for advanced level. Okay, just write down the basic concept of trigonometry. The basic concept of trigonometry is about an angle. The basic concept of trigonometry is about an angle. Let a line segment OA, which is rotated about O, as the given figure. The portion of rotation between the initial and end position, is measured by the angle. Okay. Now you just sketch this figure. This figure is sketched. Okay. With star mark write down, anticlockwise sense measured angles are positive angles. Anticlockwise sense measured angles are positive angles. Anticlockwise sense measured angles are positive angles. And clockwise sense measured angles are negative angles. Okay, you just sketch this one. Here line segment, here this rotation we call positive, and here line segment, here this way rotation we call negative. So we put here rotating direction by only one arrowhead. Here one arrowhead. Okay, rotation direction given by this arrowhead. Okay, then here this is positive and here this is negative angle. Sketch it. Okay. Next star mark. Next star mark. Right. Upward measured angles from a horizontal level. Upward measured angle from a horizontal level is an angle of elevation. Is an angle of elevation. Upward measured angles from a horizontal level is an angle of elevation. Elevation. And downward measured angles are angle of dispersion. Angle of dispersion. Okay. Now you sketch this one. Here one horizontal level. So from that you measure upward angle of elevation. Then from horizontal level you measure downward angle of dispersion. Okay, just sketch it. That is from horizontal level. Okay, horizontal level, angle of elevation, dispersion. Then clockwise, anti-clockwise, positive, negative. No, clockwise negative, anti-clockwise positive. The angle of elevation, angle of dispersion. Okay. Then further you see, you consider a horizontal level here. Here some inclination. Here this one we call inclination to the horizontal. Inclination to the horizontal. Inclination to the horizontal. Here you consider vertical line. Here angle with the upward vertical. And here the angle with downward vertical. Okay, here vertical line. Angle to the upward vertical. And here this one angle downward vertical. Okay, just write them. Here inclination to the horizontal. We call this is inclination to the horizontal. And this one called angle to the upward vertical, and this one called angle to the downward vertical. Downward vertical. Sketch it. Okay. Then further you write, there are two different systems of angle measurements. There are two different systems of angle measurements. There are two different systems of angle measurements. First one, surface measurement. Surface measurements. Within bracket, degree measurements. Degree measurement. Degree measurement. You know this, huh? Surface measurement or degree measurement. Okay, you consider a circle here. Consider full circle. So when you split that by two horizontal and vertical line, here these are we call quadrants. Quadrants. Quadrant. It subtends angle 90 at it in the center. Okay. Then full rotation, full angle we call 360 degree. Full rotation. So when we split into 360, then this small portion called 1 degree. 1 degree. So when we divide this 1 degree, 60 equal part, we get 1 minute. We get 1 minute. Then further when we divide that 1 minute, another 60 equal part, we get 1 seconds. Then 1 minute divide by 60, we call 1 second. That is we call surface measurements. Usually this surface measurement we use for practical purposes, not for calculations. We use for practical purposes. Okay? Sketch and write everything. Here full rotation 360 degree, then one segment 1 degree, then 1 degree divided by 60 we call 1 minute, and 1 minute divided by 60 we call 1 second, 1 second. That is we call surface measurement. Okay, somewhere you write down, surface measurements are used for practical purposes. 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 Okay, that is about surface measurement. Then second one that is new to you, write down radian measurements. Radian measurements. Radian measurements. Radian measurements. Okay, this is new to you. So here it is. You consider a line segment, let's say length r. Length r. So I'm going to rotate this one. So let this arc length, here this arc length equal to r. Then here r. Then this angle we call 1 radian, 1 rad. Then here radius equal to arc length. Then this angle we call, subtended angle we call 1 radian. That is somewhat big angle, but degree 1 degree means somewhat small angle, no? Then 1 minute very small. Then 1 seconds very small, no? Very small. But radian somewhat big. Therefore here 1 radian we usually denote by 1c. 1c also possible notation. 1c or 1 rad, but you better use rad notation. Okay, just sketch this one. Okay. Angle subtended at the center of a sector where the arc length equal to the radius, is called 1 radian. 1 radian. Here 1 radian approximately equal to 57.3 degrees. 57.3 degrees. Okay, just write it. No need to remember, but anyway it is somewhat big angle close to 60 degree. 1 radian approximately equal to 57.3. 57.3. That is radian. Okay, we need to use unit RAD or 1C. 1C. Okay, now you consider this. You consider full rotation. Full rotation represent 360 degree, no? Full rotation represent 360 degree. Then consider this radius r. You consider this arc length r. Then here this is 1 radian. 1 radian. Then when you consider another one arc length r, now 2 radians. So when you consider another arc length r, then here total 3 radians, no? Then we know full circumference is 2 pi r, no? 2 pi r. Then here one segment length r, so 2 pi r divided by r represent 2 pi r divided by r represent number of segments, no? Here r full length 2 pi r, here number of segment. Then number of segment mean number of radians, no? 1 radian, 2 radian, 3 radian, so on. No? Then here this 360 equal with 2 pi r divided by r in radians. So now you simplify, then 180 degree equal to pi in radians. So here this side radians. Then here relation between radians and degree. Then 1 degree you consider pi divided by 180 in radians. Then 1 radian equal pi 180 divided by pi. 180 divided by pi. Here in degrees. Here relation between radian and degree. Okay, just write radian degree relation. You better remember this one. That is radian and degree connection. Okay, that is radian degree relation. So that's one important thing. Here we can write radian in terms of pi. In terms of pi. So when we write angle in terms of pi, no need to put RAD units. No need to put unit, okay? But if you put pi as 22 divided by 7, that means pi value if you put there, then you have to write radian RAD unit, okay? That means you consider 1 degree equal pi divided by 180, no? So we write here in terms of pi. Then here no need to put unit. Unit RAD. So 1 degree equal pi divided by 180, no? Then when you put pi equal 22 over 7, 180, then it is approximate value, no? Here onwards you have to put radian unit. Okay? In terms of pi, no need to put unit. But without pi, we have to put unit. That is one thing. Okay? With star mark write down. With star mark write down. A radian angle can be written in terms of pi. Can be written in terms of pi. A radian angle can be written in terms of pi. For such case, no need to use unit. No need to use unit. But But when the value of pi is substituted, when the value of pi is substituted, when the value of pi is substituted, units must be used. Unit must be used. Unit must be used. Okay, just write this one. Okay, now let's do few conversions. Write down this question. Represent the following degree measurements. Represent the following degree measurements in radians. Represent the following degree measurements in radians. Okay, I'll do 2, 3. Here 1 degree equal pi divided by 180, no? Pi divided by 180. Then 2 degree equal twice of that, no? Pi divided by 180 times 2. That means pi divided by 90, no? Then 3 degree, pi over 180 times 3, no? That is pi divided by 60, no? Then 5 degree, pi over 180 times 5. Then pi divided by 5, here 3, 6. So on we can write, okay? Then 10 degree equal pi over 180 times 10 equal pi over 80. Pi over 80. Okay, you do them soon. Thereafter you find okay, do them soon. Do them soon. I just need only simplest form, but no decimals needed. In terms of pi with fractions, that's enough. Do it. Check your answers. Check your answers. So anyway, here you need to remember 30 degree, that is special angle, 45 degree, pi divided by 4 in radians, and 90 degree, these are special angles. Then 120, 135, 115, so usually we use them, and 60 degree, these are special angles. Okay, so better to remember directly 30 degree equal pi divided by 6, pi over 6 equal 30 degree. Likewise, you better remember all. Okay, now let's go further. Let's go further. Now these angles are given only in radians, only in radians. Sorry, only in degrees. Only in degrees. Then degree angles can be given with degree decimals of that. As an example, 30.5 degree. 30.5 degree. Then we can do same thing. Then 30.5, 30 plus 0.5 means 1 over 2. 1 degree equal pi divided by 180. Then now it is in radian. 61 pi divided by 360. Then here radian angle. Then for decimals also we can do same. 3.75 degree. 3 plus 75, 3 divided by 4 times pi over 180, 12, 15. Here it is divisible by 3, no? 60. 4, 5. 5 divided by 4, 60. Then divisible by 5 again. 5 divided by 48. Likewise, for decimals also we can do same. Do them. Okay, then similarly you try 20.25 degree, 15.6 degree, 13.1 degree, 15.25 degree. Okay, do them soon. Here we know we have negative angles, no? Twenty point 20 plus 1/4 times 180, pi divided by 180, then 81 pi 720. It is divisible by 9, no? Then 9 pi divided by 80. Then 15.6, 15 plus 6 over 10 times pi over 180. Then now it is divisible by 3, no? 5, 2, 60. Then here 1, 5. 25, 26. 26 pi divided by 5 times 60. Then 23 pi 150. And 13.1, 13 plus 1 over 10 into pi divided by 180. 131 pi 1800, 1800. Then here minus 15 plus 1/4 pi divided by 180 minus 61 divided by 61 pi divided by 720. No? Okay, then you know how to convert degree to radian, no? Then radian to degree also same. But again we have to think about how to convert minute and seconds to radian again, because we know only radian degree relation. Okay, let's do that. See this 30 point, 30 degree, 30 minute, 30 degree, 30 minute. So here 30 degree, 30 minutes, you can write 30 divided by 60 in degrees. Then 30 degree, 1 over 2 degree, then 61 over 2 in degrees. Now just multiply by pi over 180. That's it, no? Then 61 pi divided by 360. So if we have minutes or seconds, we need to convert that into degrees. See another one. 45 point degree, 20 minutes. Then you do this 45 plus 20 divided by 60. Now that is in degrees. Now just multiply by pi over 180, no? Now it is in radians. Now simplify here 1, 3, 45 times 3, 135, 136, 3, pi over 180. 136, 540. 136 pi divided by 540, no? Then if we have minutes and seconds, we need to convert that into degrees. Okay? Do examples. Let's do another one. Let's do another one. See 30 degree, 30 degree, 30 minutes, 30 seconds. You convert this into degrees. 30 plus, here 30 over 60 now in degrees. Here 30 minutes now, you divide by 60, now it is in minutes. Here 30 seconds. Then further you divide by 60, now it is in degrees. So now this is in degrees. Then you multiply by pi over 180. Pi over 180. Now just simplify this. Here 1, 2, 1, 2, 260, 120. Here 30 times 2 times 60 plus 1 pi over 180. Then you simplify and get the value. Okay, do it. Okay, you try. (15 degree) 30 minutes. 12 degree 54 minutes. 15 degree 30 minutes. 12 minutes. 15 degree 12 minutes 30 seconds. 30 degree 45 minutes 12 seconds. Do it. Okay, 15 degree 30 second. 15 plus 30 divided by 60 times pi over 180. Then 12 plus 54 over 60 times pi over 180. You simplify, yeah? Simplify 15 plus 12 over 60 pi over 180. Then 15 plus 12 over 60, 30 over 60 times 60 pi over 180. Here 30, 45 over 60, 12 over 60 times 60 pi over 180. You simplify and get the answer. Okay. Now with that one, you consider this. Now we know how to convert degree to radian and degree decimals to radian, degree minutes and seconds to radians. Now you consider here 15.5 degrees. Now I'm going to convert this into degrees, minutes and seconds, all combination without this decimal part. Then here 15 degree, 0.5 degree now. Then 15 degree, here half times 60 now in minutes. Then 50 plus 50 degree, 30 minutes. Then 15.5 mean 15 degree 30 minutes. 15 degree 30 minutes. Likewise you can convert. So here decimal format. This conversion will be for your first term test. Okay. Other than that we don't get any other questions for our A-level question. But for first term test these conversions will be there. Now consider 12.4 degree. Here you do 12 degree for 0.4. 0.4 degree now. Then you do this say 0.4 means 4 over 10. Then you multiply by 60. Now that is in minutes. No? That is in minutes. Then 12 degree, simplify, 24 minutes. 12 degree, 24 minutes. Then 12.4 degree means 12.24 minutes. So on we can do. Okay, do that examples. Okay, then you convert this. Here we have degrees with decimals. You convert into minutes and seconds. If you need seconds, then you have to do this, and for minutes as well, minutes and seconds as well. Okay, time's enough. Check your answers. Here 13 degree 45 0.55 no? Then 45 over 100 times 60. 13 degree 27 seconds minutes now. Then 15 degree 75 over 100 times 60. Then divisible by 5, 2, 3, 1, 15, 45. 15 degree 45 minutes. Then 13.15, 13 degree 15 over 100 times 60. Then here 3, 2, 9. 13 degree 9 minute. 6 degree 36 over 100 times 60 minutes. Then here 6 degree 36. Here 36 times 6. 21.6 minute. Further we have decimal now. Then 6 degree 21 minute. Then here 0.6 minute. Then right here 6 over 10. 6 over 10 times 60 seconds. Then 6 degree 21 minute 36 seconds. The last one 1 degree 54 over 100 times 60 minutes. 1 degree. Then here 54 times 6. 32.4 minutes. Then 1 degree 32 minutes. 4 over 10 times 60 seconds now. Then 1 degree 32 minutes 24 seconds. 24 seconds now. Okay. Now we know radian degree conversions. Now further we have one another relation. Check this one. You consider here this is we call a sector. Here radius r. Let's take this angle theta. Say given in radians, not in degrees, okay? Theta given in radians. Then this arc length AS, and let this area A. Then S we call arc length. Then we write S equal arc theta. You can directly apply this formula. But remember, theta must be given in radians. And further this area, we write half r square theta. Here this is area. area of a sector. Okay, just write that one. Just write it. Okay, now let's do 2-3 questions with that relation. Okay, you do with me. Here consider this angle 60 degree. Here this radius r. Then if you need to find arc length s, then theta 60 degree no? Then 60 degree in radians, pi divided by 3 no? Pi divided by 3. You have to convert that into radian. Okay, then s equal, you say r theta. Then let's take this radius 2 meters. Then 2 times theta, pi divided by 3. Then 2 pi divided by 3 meters. Then here area half r square theta. Then half r mean 2 no? 2 square theta mean pi divided by 3. Then 2 pi divided by 3 square meters. Likewise, you can directly apply that formula. Okay. Do example. First you have to convert angle into radians. Convert that angle into radians, thereafter you proceed it. You do. Here 3 meters 30 degree. Do soon. Here 45 degree, 2 meters radius. Here 15 degree, 3 meters. Okay, just find arc length and area. Do soon. Here theta 30 degree mean pi divided by 6, S equal arc theta, and pi over 2 meters, area half r square theta. Then simplify 3 pi divided by 4 square meters. And here theta 45 degree, then pi divided by 4 in radian, S equal r theta, then pi divided by 2 meters, area half r square theta, pi divided by 2 square meters. Okay, you find, you get units. Then last one, 15 degree, so here pi over 180 times 15, no? Divisible by 3, no? 5, 60, pi over 12. Then arc length r theta, 3 pi over 12, this pi divided by 4 meters, area half r squared, theta pi divided by 12. Simplify 3 pi divided by 8 square meters. Okay, now you continue. So you find perimeter and area for these cases. Find perimeter and area, shaded area. Find shaded area and perimeter. The 1 meter, you do alone. You 45. Three meter, 1 meter. Okay, do it now. Just think and do. Okay, here perimeter, here 1 meters now, 30 degree mean, theta 30 degree mean, pi divided by 6 in radian. Then perimeter, here 1 meter, 2. Then S equal r theta, r mean 1 no? Theta pi divided by 6. And for this one, r theta, r mean 2 now, pi divided by 6. Then 1 meter, r theta. Then simplify. 2 plus, here 3 pi over 6 now, that means pi over 2 now, meters. Then area, shaded area, get full sector area first. Half r square theta pi divided by 6 minus this sector half r square theta pi divided by 6. Then pi divided by 12 common, 4 minus 1 3. Then pi divided by 4 square meters. Okay, first get full sector area and subtract small sector. Take further 1 minute. Okay, here this case, perimeter, here 3, 1, then 1 plus 1, 2. 1 into 2 plus, here theta 45. 45 degree, that means pi divided by 4. Then S equal r theta. Here 3, 1 means here 2, no? R 2 theta pi divided by 4. S equal r theta. Then for this one r theta, r means 3, theta pi divided by 4. Then 2 plus 5 pi divided by 4 meters. That is perimeter. Then similarly you find area. Then full sector area, half r square theta minus half r theta. Half r square theta, you take difference. By full sector, you subtract small one. Then pi divided by 12 common, take it outside, 9 minus 4. Then 5 pi over 12 square meters, na? Square meters. Okay, for your term test there will be direct questions, but later you won't get direct questions. But while you are doing questions, you have to remember these relations. Okay. For now, we have done angle measurements and their relations. Then further we can move to trigonometry. That means the relations with triangles. Relations with triangles. Okay, especially we consider trigonometric ratios. Okay, write down. Trigonometric ratios and identities. Trigonometric ratios and identities. Trigonometric ratios and identities. Okay. Within 2 to 3 days, we can complete first trigonometry part. That means special simplification and all the identities. Those things we can complete within 2 to 3 days. But later we have discussed applications of trigonometry. Okay, those things we have to practice well. Now, so in your O levels, so you discuss the things about right angle triangle. No? Here take angle theta. Say here A, B, C. Here right angle triangle. Then you know sin theta. No? Sin theta A divided by C. Cos theta B divided by C. Tan theta A divided by B. These are we call trigonometric ratios. So under O levels you have done only 3 trigonometric ratios. But we have 6 different trigonometric ratios. So when you consider right angle triangle, we have 3 sides. No? When you take two together, Then the size ratios we call trigonometric ratios. Size ratios we call trigonometric ratios. A over C, C over A, B over C, C over B, A over B, B over A. Likewise, size ratios we call trigonometric ratios. So those things have defined for right angle triangle. But that is not full accurate one. We have to discuss further. Because this is an angle, no? Then for right angle triangle, we can represent only acute angles here. No? We can represent only acute angles here, only for right angle triangle. But angle mean one thing that can have many amount. No? Then 30 degree, 60 degree, 360 degree, so on. We can rotate again and again. Okay? Then the angle can be any amount. Therefore, this definition not possible with always. Anyway, we have another three, the other one called cosec. So here sin A over C, then cosec means C over A. Cos B over C, then we have another one sec. Cos B over C, sec C over B. Then cot. Tan A over B, then cot B over A. B over A. So now we have 6 different trigonometric ratios. Okay. Then we have different connection with each of them. So like as an example, cosec theta, C over A, no? Then A over C, then cosec theta equal 1 over sine. No? Likewise, there are some relations in between them. Then sec equal C over B, then cos equal B over C, then sec equal 1 over cos theta, or cos equal 1 over sec theta. Likewise, there are combinations, relations between them. Those combinations, connections we call identities. Okay? Okay, just write down. Just write down. The fundamental definition of the fundamental definition of trigonometric ratios deals with a right angle triangle. Deals with a right angle triangle. Deals with a right angle triangle. Different size ratios are known as trigonometric ratios. Different size ratios are known as trigonometric ratios. There are 6 different trigonometric ratios. There are 6 different trigonometric ratios. There are 6 different trigonometric ratios. They are given below. They are given below. Okay. Now you sketch this and write all. Sketch and write. Sin equal A over C, cosec equal C over A, cos equal B over C, sec equal C over B, tan equal A over B, then cot equal B over A. Okay. Now you identify here the trigonometric ratio must have angle. Okay. Angle theta must be there. Without angle, it is undefined. Definitely angle must be there. Without angle, it is undefined. Here sin theta mean a single term. Don't consider like sin times theta. Sin theta mean a single term. Sin 30, sin 60, sin alpha, sin x, all are single terms. Then sin definition, a divided by c, opposite over hypotenuse. No? Cos definition, adjacent over hypotenuse. Likewise, we have definition. Then here this is compressed format, that is a single term. Then without angle, we can't write that. We can't write that, okay? We try, star mark and write down. All trigonometric ratios must have an angle. Without an angle, it is undefined. Without an angle, it is undefined. Without an angle, it is undefined. Next line. There are different relations. Between trigonometric ratios. There are different relations between trigonometric ratios. There are different relations between trigonometric ratios. Those relations are called identities. Those relations are called identities. Identities. Those identities are true for any angle. Those identities are true for any angle. Those identities are true for any angle. Okay. Now let's write few of them. Here one is cosec theta 1 over sin theta. Sec theta equal 1 over cos theta. Cot theta equal 1 over tan theta. That is one relation. Okay. So here these are possible with any angle. That means cosec x equal 1 over sin x. Cosec 30 equal 1 over sin 30. Cosec beta equal 1 over sin beta. Okay, with any angle that is possible. Cosec 0 equal 1 over sin 0. Okay. Then all the other cases same. For any angle that is true. And further you see, here we have sin cos. So when you divide sin theta over cos theta, so right side a divided by c over b divided by c, no? Then we can get a divided by b. This is known thing, no? That is tan, no? Then sin theta over cos theta, we say tan theta. Then sin theta divided by cos theta equal tan theta. This is another one. Further we know cot mean 1 over 10, 1 over 10, 1 over 10 mean you can take reciprocal, no? Then cos theta over sin theta will be cot, no? Cos theta over sin theta will be cot theta. So here these are we call identities. Here these are called trigonometric ratios. Then trigonometric ratios means side ratio, but identity mean not side ratio, the relation between them, no? Then cosec theta 1 over sin theta, sec theta 1 over cos theta, cot theta 1 over tan theta, sin theta over cos theta tan, cos theta over sin theta cot, no? Same angle theta. Then cot theta equal 1 over tan, cot x equal 1 over tan x, sin 30 over cos 30 equal tan 30. Likewise for any angle that is true. These are we call identities, fundamental identities. Okay, just write fundamental identities, write them. Again we have special identity called Pythagorean identity. So under all of us we have done Pythagorean theorem, no? Now this is about Pythagorean identity. That is another thing. Okay, write down subtopic Pythagorean identity. Pythagorean identity. Pythagorean identity. That comes with right angle triangle. Huh? Okay, check this now. So I'll take this diagram. Then we know Pythagorean theorem. A square plus b square equals c square. No? This is Pythagorean theorem. Pythagorean theorem. Now I'm going to divide this one by c square. A square over c square, b square over c square, c squared over c square. Here a over c square, b over c square, 1. Okay. And further, here this is special note. Sin theta times sin theta. We write this one sin theta to the power 2. Sin theta times sin theta we call sin theta to the power 2. Here we can write sin square theta. Sin square theta means sin theta to the power 2. And it is sin theta times sin theta. All the other trigonometric ratios we can use that notation. Then similar here, sin theta times sin theta, you say sin cube theta. Don't put 3 here, you put within sin and theta the power. Okay, that is general notation. Then a over c A over C, we know that is A over C sine theta, no? B over C cos theta. Then write sin square theta plus cos square theta equal 1. This is we call Pythagorean identity. Sin square theta plus cos square theta equal 1. Then here theta can be any angle. Then sin squared x plus cos squared x equal 1. Sin squared alpha plus cos squared alpha equal 1. Sin square 30 plus cos square 30 equal 1. Sin square alpha plus cos square beta, that is not equal 1. Na? Angle must be same. Then sin square 45 plus cos square 40 will be 1. Then angle must be same. This is we call Pythagorean identity. Okay, do that proof. Again you sketch new figure. Sketch new figure and do it. Okay, now see, again we have another two relations. Check this now. Here say this one 1, sin square plus cos square 1, sin square theta plus cos square theta equal 1. You divide every term by cos squared. Then we know sin over cos. Here sin over cos equal tan. No? 1 over cos equals sec. 1 over cos equals sec. So then another identity. Cos cancel. Sin over cos tan. 1 over cos sec. Then this is another format of Pythagorean identity. We have another one, sin square theta plus cos square theta equal 1. Now you divide every term by sin squared. Then cancel this. Cos over sine we call cot. 1 over sine means cosec. Then this is another format of Pythagorean identity. We have three different forms of that. You just remember sine square plus cos square 1. 1 equals sine square plus cos square. Then reverse order you have to remember. Then sine square plus cos square 1. Then sine squared equal 1 minus cos squared. Cos squared equal 1 minus sine squared. Then 1 minus cos square equals sine squared. 1 minus sine squared equal cos squared. Likewise, you have to remember different combinations. Not only one, but also every combination you better remember. Then we can move to any question. Then cosec equal 1 over sine. Then 1 over cosec equal sine. Cosec into sine equal 1. Likewise, you remember different combinations. Sine square plus cos square 1. 1 equals sine squared plus cos squared. Sine squared equal 1 minus cos squared. Cos squared equal 1 minus sine squared. And reverse order. Then all better to remember. Okay, do them. Now here we have identities, all are identities, okay? All are identities. Here 1, 2, 3, 4, 5, 6, 7, 8. Up to now we have 6 different identities. You remember all and remember different combinations again. Okay, I'll do one another theory part. Write down last theory part. Actual definition of trigonometric ratio. Actual definition of trigonometric ratios. Actual definition of trigonometric ratios. Okay, check this one. Now you know trigonometric ratios now. So those trigonometric ratios we have defined for right angle triangle, no? Right angle triangle. So in right angle triangle, angle will be acute angle, no? Acute angle. But angle can be any amount. Angle can be positive or negative. But right angle triangle has only acute angles. Right angle triangle only acute angle. But trigonometric ratios can deal with any angle. Therefore, that previous definition not fully applicable. Okay. Then sin 30, we can sketch right angle triangle and we can get it. But sin 120, we can't sketch right angle triangle. No? Sin 120. For 120, no right angle triangle. Then we need definition for that. Just write. The above definition of trigonometric ratios. The above definition of trigonometric ratios. The above definition of trigonometric ratios deals with a right angle triangle. Deals with a right angle triangle. Deals with a right angle triangle. The corresponding angle is an acute angle. Corresponding angle is an acute angle. But any trigonometric ratio must have definition with any angle. With the coordinate system, the actual definition can be given. With the coordinate system, the actual definition can be given. Okay, check this. For acute angles, previous definition, okay. But here this will be actual definition. You consider point P here. So let's say x comma y, which can rotate. Here it create a circle. Create a circle. Then take this angle theta, take this radius r. Okay? Here onwards you say sine theta, y coordinate divide by here this length of the line segment, length of the rotating line segment, length of the rotating line segment. Cos theta you say x coordinate over length of the rotating line segment. Tan theta you say y coordinate over x coordinate. So that definitions comes with coordinate system. So coordinate can be positive or negative, length only positive, then when it rotate, then xy sign change, no? First quadrant xy are all positive, but second quadrant x negative, no? Third quadrant xy both negative, fourth quadrant y only negative, no? Then according to that, with those quadrant, trigonometric ratios can be positive or negative. But anyway, this is we call actual definition. Okay, you sketch this figure first and thereafter write their definitions. Okay.